Hello, grade 12s. Welcome to this lesson about inverse functions. We are on video 19, and I trust that all the 18 videos that I've uploaded and really, to your benefit, you've watched them, you've learned a lot, and your mathematics is improving, and you get to a point where, or you are really getting to a point where, you are mastering this subject and you are loving it, and having fun. All right. So the concept of inverses, what is it about? I trust that at this point you have some basic knowledge about inverse functions. And here we are really transforming one function to give us a new function called its inverse. Okay. And the word inverse just implies, the opposite of something in simple language. So if you want the opposite of x, if you are in the xy plane, okay, the opposite of x will be a y, and the opposite of y will be x. Again, the opposite of domain is range. What is the opposite of range? It's domain. Okay, so that is what we are doing, okay, in this topic. And by looking at the equation that is given in any question, you need to be able to identify the kind of function it represents. Okay, so let's start with the question and let's see what we can, come up with, what we can learn, and what relationships we can, form through inquiry. Given f of x is equal to 2 to the power of x, what type of function is this? I hear an exponential function, that is good. And g of x is equal to 2 over x minus 1, and this fraction we minus 1. What type of function is g? I hear a rational function, or some of you may say a hyperbola. Okay, excellent. So we have 4 questions here based on these 2 equations that we see, or the functions that are given. Okay, so this is an exponential function, and this is a hyperbola. Okay, so my advice is that always, associate the equation to a sketch, because we are visual beings and we learn better when we see, something, over and above hearing it or just knowing it, verbally. So if you look at the sketches of this, your base is 2 to the power of x. What is the asymptote here, horizontal asymptote? It will be the x-axis. Is it an increasing or decreasing function? The coefficient there is positive 1. So it's an increasing function and it will cut the y-axis at 1. Okay? Good. So that is just a sketch. You don't need to really calculate x-intercepts and y-intercepts at this stage. It's just to help you to, conceptualize what you are dealing with. So this is a hyperbola. We understand that it has 2 arms. Okay. So your a here from the format is positive. So you expect your arms or your curves to be in quadrant 1 and quadrant 3. Okay. So what does this give you? The denominator, in standard format, will always give you the equation of the vertical asymptote, where this vertical line cuts the x-axis. Okay, so this is the x-axis, that is your y. And you always take the opposite side. Okay, so why do we take the opposite side? Because we're looking at where the denominator is equal to 0, and we transpose the minus 1, it becomes positive. Alright, because when the denominator is equal to 0, this is undefined, and by definition, an asymptote is a boundary. Okay, it's that x value or y value where the function is undefined. Good. So we are here at 1, there will be a vertical asymptote. And here it's a minus 1, so there will be a horizontal asymptote at negative 1. Okay. So here's your arms, and another one will be there. Okay. Remember, the arms of the curves are allowed to just approach, and of which they do, approach the asymptotes, but not touch them or cross them. Okay. So that is what we have. So let's start with the what type of function. We get the progression. Is it a decreasing function or an increasing function? It's a decreasing function, because looking at from left to right, it's going down, it's going down. Okay, good stuff. Write down the equation of the inverse of f. So here we, by now I think, understand the procedure of finding the inverse. So x and y are your what? Set of coordinates in the Cartesian plane. So when you want the opposite of y equal to something, you swap your variables. Your x becomes the y, your y becomes the x. And that is why we say we start that way. X is equal to 2 to the power of y. And then you solve for y, which will represent the new function called the inverse of what? F. So in this case, using laws, the inverse function will be, the base is 2, so it is log base 2 of x. Okay, so the inverse of an exponential function is the logarithmic function. If you started with the log function, you will get this one, where the inverse is an exponential function. All right, I believe we're together so far. Great stuff. Let's do the same for g. What is the inverse of a rational function of this nature, or a hyperbola? Okay, it's not usually common, but let us find out what comes up when we find the inverse of a hyperbola. So y, okay, is equal to 2 over x minus 1 minus 1. Okay, exchange, right, x and y. So this is x equal to 2 over y minus 1 minus 1. Okay, every other constant, you keep it where it is. Okay, your interest is initially on the variables. Okay, good stuff. So you need to perform, some algebraic steps there. Simple, straightforward. You transpose the minus 1, it becomes a plus 1. Okay, and you cross multiply and you invert. It's up to you how you want to do it, but then you end up with, from here you end up with y minus y equal to 2 over x plus y, and therefore the inverse is obtained by transposing ultimately the minus 1. So therefore g inverse of x is equal to 2 over x plus 1 plus 1. Oh, so what do you notice? The inverse of a hyperbola is a what? It's a hyperbola. All right, interesting. Okay, however, what do we see? We had a minus 1 here, we have a plus 1 there. We had a minus 1 there, and there is a plus 1. What is the inverse of a negative? It's a positive. Inverse of a positive is a negative. You see, again, the word opposite comes up again. All right. And then if you had to sketch this, again, we'll go back here and say, now my vertical asymptote is at negative 1, and my horizontal asymptote is at 1. Okay, my A is still 2, and therefore my arms, so my curves, are in quadrant 1 and 3. So there is it, and there is it. Okay, so interesting relationship there. Good. So let's go to C. Write down the domain of the inverse of f. You have the equation, but you don't have the sketch of the log function. All right? Base it on your sketch of the original function. Remember, domain will come from the range of the original function. Yes, that is the relationship. The range becomes the domain. So what is the range of the original function? It is y greater than 0. Okay? So the domain of the inverse function will be x greater than 0. Again, it was a range in the original function, y greater than 0. You swap the variables, x greater than 0. Okay, or if you like, you can write it in interval notation. X element of 0 to infinity. Okay, and that is the domain of the log function there. Good. Now write down the equations of the asymptotes of the inverse of g. Okay, we do understand that there has been a change in the positions of the asymptotes because we are reflecting in the line y equal to x, and it affects both the horizontal and vertical asymptote here. So I'm going to use HA to mean horizontal asymptote and VA to mean vertical asymptote. The horizontal asymptote is a positive 1, so it's y equal to 1, and this one is y equal to what? Yes, negative 1. Okay, so that is what we have, grade 12s, and I want to really encourage you to master this topic and it's be beneficial to you. Okay, so thank you very much for tuning in and all the best. See you next time. Sharp, sharp.